Now we're going to talk about something called solving combined inequalities. So in the last lesson we looked at solving just one inequality, and our range of answers went from some number to infinity or from negative infinity to some number. But in real life, a lot of situations actually utilize two inequalities that are kind of thought about together to provide endpoints on either side, so that we're not thinking all the way to infinity. A perfect example of this would be when you're driving on the highway. So there's a minimum speed limit and there's a maximum speed limit. On the highway it says that you're supposed to drive greater than or equal to 45 miles an hour, but also you're also supposed to drive less than or equal to 65 miles an hour. So in order to get the range of acceptable speeds on the highway, we're thinking of two inequalities combined together to create the endpoints of 45 to 65. So that's a lot more reasonable than thinking of 45 to infinity or negative infinity to 65. So that's what we're going to look at today. So we need to start with a couple of vocabulary words. And these are kind of scary words, but the ideas are a lot easier than you think they're going to be. The first one is called a conjunction. Conjunctions rely on the word and. So it tells us we're looking at two inequalities. We want to know where they both are true. So the example that I just told you guys about the highway, that would be considered a conjunction. We're looking for places where the speed is greater than or equal to 45 and less than or equal to 65. So that's a conjunction. The other thing we might have is called a disjunction. And the word that keys us into that is or. So in a disjunction, we're looking at two inequalities and we just care about where one of them is true. And notice that I wrote the words at least one, because we don't care in a disjunction if they're both true. That doesn't bother us at all, but we care that at least one of the two inequalities is true. Okay? So really the most important thing about these is you got to see some examples of them. Conjunctions are often written in one kind of inequality looking thing. So there's two inequalities happening here, even though it looks like one. There's this, which says 3 is less than 2x plus 5. But there's also this one that says 2x plus 5 is less than or equal to 15. So rather than writing these out as two separate inequalities, generally when both of the inequality signs are going in the same direction, we just write it as one. It makes it a little bit easier. Now to solve this conjunction, our goal is to get the x that's in the middle here by itself. And so just like with an equation, what you do in the middle here, you're going to do to both sides. So same steps, we're going to start by subtracting 5. And we're going to do it to all three parts. And then, to get the x alone, we need to divide by 2. And again, we're going to do this to all three. And this gives us our range of acceptable answers. Now, although I'm not requiring you to do the number line to graph these, you may want to look at the number line just to get an idea of what's happening here. This reads that x is less than or equal to 5, so that's the part I'm going to color in red. But it also says that x is greater than negative 1. So let's take the two of those together. So x is less than or equal to 5. Because there's an equals to sign, I use a closed dot, and I'm shading to the left for less than. Left goes less than. Then the other one, x is greater than -1. Because it's a greater than, and there's no equals to underneath it, I'm going to use an open circle, and I'm going to shade to the right. Now the answer to our conjunction, because remember a conjunction says, where are they both true, is where the two colors overlap. And they overlap between -1 and 5. So a lot of times your endpoints will be written right in there. It's kind of easy to see. So the smallest number x can be is -1, the biggest number, 5. So in interval notation, the smaller number goes on the left, the bigger number goes on the right, and notice that I'm using a parenthesis with a -1 because there's no equals to underneath it, and I'm using a bracket on the side with the 5 because there is. So this tells me my acceptable answers range up to 5, including 5, and get as small as -1, but they don't actually get to -1. They have to be just a little bit bigger. So that's an example of a conjunction. You can also see the same example written like this. So 2x plus 5 is greater than 3, and 2x plus 5 is less than or equal to 15. And you would just solve these separately, and it would end up giving us the same sort of thing we did last time. It'll give us a range of answers. So on this side it says x is greater than -1. On this side, x is less than or equal to 5. So when we combine those together, that it has to be bigger than -1, but less than or equal to 5, we get that same interval that we had before. So it doesn't matter whether it's written like this in a combination or whether it's written separately. The word "and" tells us that it's a conjunction and both have to be true. Let's do another example of a conjunction. So there isn't a lot of solving that needs to happen here because x is already by itself. But we have to figure out where on the number line are both of these going to be true. And again, graphing the number line is optional, but it may help you to visually see what's going on. So I'm going to use red for that, green for that. So x is greater than 3 gives us open circle at 3 going on to the right, and x is greater than 5, open circle at 5 going on to the right. So notice that our lines start to overlap starting at the 5. So this area right here, while it works for one of the inequalities, it doesn't work for both. So the only part we care about starts at 5, and both arrows are going in the same direction. They're going to the right. They're going to positive infinity. So the interval where both are true ranges from 5 to infinity. Now let's take a look at a disjunction. Now, disjunctions are usually written as two separate things, often because it's really kind of weird looking for them to be put together because the inequality signs are pointing at each other or away from each other. So they're often written separately. So we just go ahead and we simplify both of them, solving for y. So on the left-hand side here, I'm going to subtract 7 from both sides. Then I'm going to divide by -2. Remember, when we multiply or divide by a negative, it changes the direction of our inequality. So this becomes y is greater than or equal to 3. So this is the left-hand one. Now we'll do the right. And notice we have y's on both sides, so we're going to start by getting our y's together. And then we move the number over. And divide. -6/4 doesn't reduce exactly, but we can make it into a fraction, -1.5 or -3/2. So we have two things happening here. We have y is greater than or equal to 3, or y is less than -1/2. Again, you don't have to graph these, but if you want to look at that, closed circle at 3, pointing to the right. For the other one, we have an open circle at -1.5, moving to the left. So remember that with a disjunction, all we care about is where is there a line. So we're going to have two distinct intervals that are our answer. This side, -∞ to -3/2, or this side, which includes its endpoint of 3, to +∞. So our answer to this disjunction is these two intervals that we have to put them together. And notice again that I use the word or in the middle because I don't want where they're both true, I just care where each one of them is. So that's an example of a disjunction. We can try another one just to make sure you guys are okay with it. Okay, so again, it's written as two separate inequalities. We're going to go ahead and solve both of them. So on the left-hand one, we have m is less than -7. Remember, we have to make a sign change here. When we change the signs, that's the same as dividing by -1. It's going to reverse the direction of the inequality. So we have two intervals here. M is less than -7 or m is greater than 7. If you want to graph them, go ahead and do that. Open circle at -7, shading to the left. Open circle at +7, shading to the right. And again, we just want to write intervals to reflect where both of those lines occur. We don't care that there's overlap. So we have an interval that goes from -∞ to -7, or +7 to +∞. You need to have both parts of those as your answer. So this should get you started with solving combined inequalities, conjunctions, and disjunctions. You want to make sure that you study those vocabulary words, make sure you know which one's which and what they mean, and go ahead and get started on doing some practice problems.